sure as we go through this, you know, if I'm doing things on my calculator, make sure you're doing them on your calculator so that you know if you're not getting the same answer and you have time to ask those questions. Please follow along. Don't just copy things down off the board. We are doing this to prepare for your test, so use this wisely. So the first question, this is kind of from section 10.1. You can expect something like this on the test. So we said the mean outstanding credit card debt for college graduates was $3,173 in 2010. A researcher believes the amount has decreased. So the null and alternative hypothesis. First thing I'm going to be looking for is, are you using the right variable? Okay, I might say the standard deviation. I might say the proportion. I might say the mean. This one was talking about the mean. What variable do we use for the mean? Yeah. So my null is that the mean is 3,173. What's my alternative? Okay, if I said it had increased, you would do greater than. If I said it has changed, that would be not equal. Okay. B, type 1 error. Okay, you have to know the different types of error. Type 1, in general, what that means is what?
Reject the null and deny the true.
Okay, so what that means is that would be concluding the mean is less than $3,173. So rejecting the null, concluding the alternative when it is not. Okay, these errors. It's not difficult, but you do need to take a little time and look back over that for tomorrow so you know which is which. Type 2 is when you fail to reject, but you should. So that would be concluding the mean is still $3,173 when it has actually decreased. Both of these, they're an error, so you made a mistake. Basically, in type 1 error, I like to remember the ones. In type 1 error, you conclude the alternative, the H sub 1. So type 1, you conclude H sub 1. So you're concluding this, but you shouldn't have. So we are concluding that the mean is less than, but it really is still the same. So that means type 2 is the opposite, when you are concluding the null hypothesis, but it was actually false. Okay, do you guys understand the difference between those two?
On my example for the type 1, I had at the end when it is instead of when it is not in my notes. So like,
Did you say like, well, I might have said when it is still the 3,173. And that's fine. Okay. D. These aren't talking about error. I'm just saying, what sentence would you write if I asked you to write a sentence when the null hypothesis is not rejected? So if you did not reject the null, that means there is not sufficient evidence to conclude the mean is less than $3,173. So if I asked you to do that on the test, I'm asking for the sentence. So I'm not just saying, tell me reject or fail to reject. I'm asking what that means. In hypothesis testing, I'm never actually proving that the null hypothesis is true. Okay, if I fail to reject, that doesn't mean I have proven that the mean is still the $3,173. It just means that I haven't proved it's not. Okay, so there was not enough evidence to conclude that it has changed. Then E, if we reject, that means there is sufficient evidence. To conclude the mean is less than $3,173. So this question, outside of the type 1 and 2 errors, it's really what we do on every hypothesis testing problem. We write a null and alternative hypothesis. We make those conclusions. A lot of times I just ask you to reject or fail to reject, but I could at any point ask you to write a sentence saying what that means. And so it's basically we have enough evidence to conclude or we don't have enough evidence. And that's all we're checking. Are we okay there? So you might need to make yourself a note, review those type 1 and 2 errors. Probably have a question like this on the test. I'm not trying to surprise you, so your test is going to look a lot like this study guide. So question number 2. I know we only asked about C, but we might as well just run through the whole thing. A and B are pretty quick. So it starts out the proportion. So when I'm writing my null hypothesis, what variable do we use? P. The proportion is 0.733. A student believes the proportion is different, so the alternative would be that P is not 0.733.
Does it matter if we use P or P hat, or what's the difference?
No, really they both represent the same thing. P hat is kind of the standard for the one instance that we observed where P is more like the population, but no, I wouldn't count. All right, part B asks us to verify the conclusion. So you have to know the two different types of requirements. We did this on our last test too. Anytime I'm talking about the mean, what's my criteria? Right. I either have to tell you the data is normal or I have to tell you my sample is 30 or larger. If I'm talking about P, that's when we have to check the N times P times 1 minus P is greater than 10. We also need to verify that the sample is less than 5% of the whole population. I think we can conclude 100 is less than 5% of the population. So my N here was 100, my P 0.733, 1 minus 0.733. And that gives me a 19.577, so that's definitely bigger than 10. So on the criteria, you don't have to show me a lot of detail, but enough that I can tell you know what your criteria is. All right, C, test the hypothesis by hand. If I'm talking about P, then what do I need to calculate? The Z. If you are confused, look at your formula sheet. We are on chapters 10 and 11 of this. Chapter 10 was when we had one sample, and chapter 11 was when we had two samples. If you look, under chapter 10, you have two different test statistics. You have a T and a Z. And you can see the Z is the formula that involves the P in it. So that's one we need to use. We are going to need a P hat here. So if you remember, P hat is just X over N. So my X was, and my N was 100, so my P hat is 0.78. So then we need the Z for the null, or for my test statistic. So we do P hat, or R value, 0.78, minus, if you're looking at that formula sheet, it's P sub 0, or the P of the null, 0.733. A lot of times, remember, I would come out here and kind of write these things just to help make sure we knew what we were doing. The mean is always just the P of the null hypothesis. Then divided by, depending on which formula you look at, if you're looking at the test statistic, you can plug it all in. A lot of times we would do the standard deviation out to the side. So that is just our P times 1 minus P over N. And again, all of that is on our formula sheet. Is everybody with me so far? Alright, so then my Z value is 1.06. Okay. We need to find the probability that Z, because of my null hypothesis, I'm saying is not equal to this. I have told you before, and this will stand true on the test, on the one that I have you do by hand on the test, I will not do it as a not equal. It'll be either a less than or a greater than. When you go to read this from your table, if it were a less than, we're looking at the Z, the normal table, because my variable is Z. You can tell that's just the number on the table from the shading. So less than, you would just read it from the table. If I said greater than, what would you do? 1 minus. Okay, not equal to. What that means, we have this normal table. Here is when my Z is 1.06. What would be the Z down here? And we can't be in either one of these tables. So what we essentially have to do is find both of those probabilities. Now we know this table is symmetric, so I could really find one of them and then just multiply it by 2. All right, would it be easier to do the less than or the greater than one from the table? Less than. So let's look up negative 1.06. And that is 0.1446. So that gives me the probability that you are in this table. We know that this would be the same, so if I just take that times 2, we get 0.2892. So that is my probability. Again, I told you the test, I'll do a slightly easier one. I won't do the not equal to. So it'll just be either a less than or a greater than from your table. All right. I asked you to state your conclusions. So we always compare this to alpha. My alpha was 0.15. So I see this is greater than alpha, so that means we fail to reject the null hypothesis.
I have a question. So what if we did it the other way, like instead of find the negative 1.0?
You looked up the positive?
Yeah, and then I did 1 minus that.
That should give you the same thing.
Okay.
Yeah, that's what I did too.
If you look up positive 1.06, that's 0.8554.
Then you take that times 2.
So 1 minus 0.8554 is 0.1446,
Yeah.
and then take it times 2. So you should get the same thing. Other questions? Okay. Let's talk about problem 3 then. This one says, a professor recommends his students spend 480 minutes outside of class studying each week. The number of minutes each student in class spends doing online assignments is recorded. Assume the data is normal. Does this suggest students are studying less than the recommended at the alpha equals 0.05 level? So what would I do first? Okay. We are ultimately asking for you to draw some conclusion because I'm giving you an alpha level. So I would expect you on your test to write a null and alternative hypothesis. You can't ever tell me you reject or fail to reject if you never had a hypothesis to begin with. So if I did this, what variable am I talking about? The mean. So the null would be that the mean is, what was it, 480? And he wants to know if they are studying less. So the alternative would be the mean is less than 480. All right, so now let's go to our calculator. All right, so we need to enter this into our L1. All of this goes in the same list because it's just one set of data. All right. We are wanting to get our t and our p. When we're talking about the mean, our variable is always t. When we're talking about the proportion, our variable is z. So we go to stat tests. Which test do we want? Number 2, a t-test. Okay, basing off data or stats? Data. Mu of the null hypothesis. The mean of my null hypothesis is?
480.
What list did I put everything in? Okay, we are testing less than. So we get our t is negative 1.5768. The p is 0.07296. Remember my alpha was 0.05. So my p is greater than alpha, so what does that tell me? Fail to reject. There is not enough evidence to conclude that his students studied less.
In the question, like, I like the sentence about sufficient evidence because it says does the evidence.
Yes.
So I don't know like when to write it and when not to.
I mean, you're never going to be wrong by writing it. On the test, when I'm looking for a sentence, I will either say write a sentence. If I just say state your conclusion, you can say reject or fail to reject. If I say explain this, then I'm looking for a sentence. So if you wrote a sentence on this one, there is not sufficient evidence to conclude that his students studied less than the 480 minutes. All right. Number 4. All right, to determine if the mean is more than 100, a sample of 35 is obtained from a distribution. The sample mean is 104.3 and the sample standard deviation is 12.4. Null and alternative. Your null hypothesis is always based off the population, not the sample. We're talking about the mean, so that's our variable. We are trying to decide if it's more than 100. So what would my null hypothesis be? The null would be equal to 100. The alternative is greater than 100. Null hypothesis is always has an equal to in it. All right, part B, checking our criteria. Since we're talking about the mean, what's my criteria? We're looking at a sample of 35, which is bigger than 30, so we are good. We can assume it's normal. Okay, then I asked for you to test this by hand. So you have to be able to show me this work. What variable do we use if we're talking about the mean? T. If you want, might be a good idea to come out and write down the mean and standard deviation for our sample. So the mean would be what? 100. The standard deviation for T. If you forget how to calculate these things, we have these formula sheets, and this is kind of going back to the previous test. If you look under Chapter 8, the first bullet has the mean and standard deviation if you're talking about x bar, the sample mean, which is essentially what this is. You've got a bullet there that also talks about the mean and standard deviation for p hat. So you don't have to memorize how to find those. It's all on our formula sheet. You also have the option of just looking at the test statistic formula under Chapter 10. It's just a little bit nastier, so we usually kind of broke it down and did it in steps. So the standard deviation of this, we do our sample standard deviation, maybe, except my program is frozen. Maybe. My computer has been struggling this week. I don't know what's going on. Okay, sample standard deviation, which it told us in the problem, was 12.4 divided by the square root of n. And we get a standard deviation of 2.09598. All right, so then to find our t-value, we do our value, or x bar, the mean of our sample, which was 104.3, minus the mean of the population, divided by the standard deviation. Just like finding a z-score, which we've done quite a few times at this point. So then if we divide that, we get 2.0515 for the t-value. All right, look at your t distribution. Remember, this table is different. The t's are the numbers inside the table. Across the top, we have our probability. And down the side, it has degrees of freedom. How many degrees of freedom do we have in this one?
34.
Good, and nice one. So we go to row 34, and then we go across to find as close to 2.05 as we can get, which is the 2.032. So the probability there is 0.025. Okay, my alpha on this one was 0.05. So p is less than alpha, so we would reject the null. That means if I ask for a sentence, there is sufficient evidence to conclude that the mean is now greater than 100. Even if I ask you to do these by hand, guys, you could always use your calculator to double check yourself if you weren't sure if you'd done it correctly. What test would we be doing here?
2.
Yep, so you go stat test number 2. Are we basing it off data or stats? Stats, mean of the null was 100. My x bar was 104.3. Standard deviation of my sample, 12.4. N was 35. Testing greater than. And we get the same t-value, 2.0515. Probability will be slightly different, which is how I'm going to know if you did it on your calculator or on your table, because they don't always match up. But we see that they are very, very close. This gave us 2.02399, and we had 0.025. So you can double check yourself that way. All right, is number 4 okay? Number 5. So golf balls are required to have a diameter of 1.68 inches. A random sample was collected, diameters were recorded, assume the data is normal, construct a 95% confidence interval to determine if the balls meet the standard. So I'm not just making the confidence interval, I'm asking you to make a conclusion here. So you do need a null and an alternative hypothesis. Am I talking about mu or p?
Mu.
Mu. So the null mu equals 1.68. We are trying to decide if they meet the standards, so what would my alternative be? Not equal. We don't want them to be bigger or smaller. So then where do you go to? What do we do? Yeah. Stat, edit, put everything in L1. And then when we go to tests, what test do I want here? We're looking for an interval. So if you're looking for, our variable was mu, so we know it's a t. So we need to go down to number 8, the t interval. We're basing it off data. We put everything in L1. Frequency should be 1. Confidence level is 0.95. And so we get 1.6782 to 1.6838. How do you decide from this if you reject or not?
If your probability is inside, it will fail.
If your mean's inside.
We look at this. Is that included in my interval?
Yes.
Yes. So we are 95% confident the mean is between these two numbers. Since my null hypothesis is between those, we fail to reject. I asked you to explain your conclusion, so that would be writing a sentence. So we are 95% confident. The mean is between the 1.6782 and the 1.6838. Because that includes our null hypothesis, that means the balls meet the standards. Do you have a question?
So, we fail to reject because we don't want the mean to be in there because like we're testing it to be not equal to, or is it always like that?
We are assuming the null hypothesis is true unless proven otherwise. So our confidence interval is based off really the data from the null hypothesis, or from the alternative hypothesis. We're looking at our sample data. So we've said from our sample we're 95% confident the mean is between these two values. Our null hypothesis falls in between them, so we can't reject it. Now, if my null was 1.5, 95% of the time it's between these two numbers, 1.5 isn't in there, so then I would reject. Do you have a question?
I accidentally deleted L1 to get it back.
Yeah.
I didn't mean to press delete when it was on.
How do you do it? Just so
I just usually reset the memory. There's another way, but it's a lot faster just to reset your memory.
My calculator is like broken because everything else works, but then on that one, it like, if you enter it and then it just disappears.
That's what I'm about to turn it back in.
But everything else works fine.
You're so fine.
Your batteries are low.
My God.
So I have a feeling it might be that that's taking a little bit longer to calculate and it's shutting itself off to conserve memory. Okay. Is that one all right? Okay, question number 6. Suppose the muzzle velocity of rounds fired from a gun were measured using 2 different devices. After 12 observations from each device, oh, I skipped number 5. All right, I'm doing number 6 because I'm ready. We did?
We skipped
That's
number
the
6.
That's just the last one we did.
Oh, sorry. I'm looking at an old version of the study guide. I pulled out another one to give you extra problems if we ran it.
I don't remember anything about it again.
Okay, let's look at number 6 on the study guide I gave you. The proportion of patients who visit the ER and die within a year is 0.05. Suppose a hospital administrator is concerned that his ER has a higher proportion. In a sample of 250 patients, 17 have died. So state the null and alternative hypothesis. What variable am I talking about? P. So the null is that the P is 0.05, so the alternative, he thinks his is higher, so greater than 0.05. B, what requirements do we use if we're talking about P? Mm-hmm.
Unless I'm
Right. My N is 250, P 0.05, 1 minus 0.05. For the sake of time, I'm just going to tell you that comes out to be like 11.875, which is bigger than 10, so we're good there. 250 is less than 5% of the entire population, so we're good there. C, I did not specify that this one had to be by hand, so we can do it on the calculator. So we go to stat test. If I'm talking about P, what test do we use? We're looking for a Z. Now there are a couple different options. You will know if you pick one that doesn't work. Like if you just hit number 1, Z test, it's going to ask you for a mean, a standard deviation. Do I have any standard deviation given in my problem?
No.
No. So we need number, what? 5, 1 proportion Z test. So P sub 0, the P of the null is 0.05. My X was 17. My N is 250. We are testing greater than. And so then it tells me that my Z is 1.0359. My B is 0.0958. Alpha was 0.01. P is bigger than alpha, so fail to reject. Part D was asking you to make the confidence interval. So we go to stat tests. Which one?
0? No.
Okay. Again, if you try, number 7 says the interval, but if you try it, it's not going to, you don't have the information it's asking for. So you go back and look. We want A, the 1 proportion Z interval. So we do either a 1 proportion Z test or a 1 proportion Z interval. So my X was 17, my N was 250, confidence level is 0.99. And so it tells me it's 0.02699 to 0.10901. Then I ask you to interpret it. So that means we are 99% confident. Our proportion, so is between 0.02699 and 0.10901. Again, if I ask you to accept or to reject or fail to reject from this, the null hypothesis was 0.05. Is 0.05 in that interval? Yes, so that's why we would fail to reject, because the null hypothesis is included in there. All right, so that first page, front and back, that piece of paper, that's the chapter 10 stuff. The next page we got into chapter 11, and you can tell this because what suddenly changed on all of these problems? There's 2 sets of data. So when we have 2 samples, that's when we're looking at the chapter 11 stuff. Okay, problem number 7. We want to see if an individual's arm span is equal to height. So we collected the following data. Why is this dependent or matched pairs data?
It's the same person.
Yeah. both measurements were from the same person. I didn't take AJ's arm span and Corey's height. I got AJ, arm span and height, Corey, arm span and height. So we're comparing the data to the same person. When you are talking about matched pairs or dependent data, the null hypothesis is always the same. So I always think dependent, that has a D in it, so that's when we're talking about the mean of the difference. So the null is the mean of the difference is 0. The alternative then, mean of the difference, we are trying to just see if this is equal, so it would be not equal for the alternative. So now we want to test that. So what do we do with this? Okay, we need to put them in L1 and L2. So put the height in L1. The arm span in L2. And then for the third, what do we always do when we're talking about the difference? Right, you go up on top of the list title. So go up on top of L3 and type L1 minus L2. All right, so now we are only going to use that third list for everything. And then it's back to what we were just doing. We're talking about the mean, so we know what test do we need to do?
2.
All right, so stat test number 2. The mean of the null, are we basing off data or stats, first of all? Sorry. Data. The mean of the null is 0. Stat, or the list should be L3. We are testing not equal to. So if we calculate, we get T is negative 0.3924. Our probability is 0.7039. Alpha was 0.05. P is most definitely less than alpha. So we fail to reject. There is not enough evidence to conclude that arm span and height are different. Is that one okay? Just got a couple minutes left. I'm going to try to quickly get through the last little bit. Okay. So problem number 9. When you're reading that, it says, suppose the following matched pairs data. So I have already told you this data is matched pairs. That means it's dependent. So how are we going to set it up?
Mean of the difference equals 0.
Talking about the mean of the difference again. So, part A, the null hypothesis. Mean of the difference is 0. Part B, or the alternative hypothesis, we are testing if the mean of the first group is smaller. So that means the difference will be less than 0. Okay, I asked you to find D bar and S sub D. That's asking for the mean and standard deviation for the difference. So what you need to do is enter your data in L1 and L2. So the X's go in L1. And the Y's go in L2. And then since we're talking about matched pairs, we have to do the difference. L1 minus L2. So now what I'm asking you to do is basically the mean and standard deviation for that difference. So if you go to calculate one variable statistics for L3, it tells you the X bar, so the mean of our difference is a negative 0.1667. standard deviation of that is 0.4502. Does everybody see how we got that stuff?
Wait, did you subtract the?
Yes, I did L3 being the first minus the second.
What test did you go to?
This was just stat calculate one variable statistics.
And you knew that because of what?
Just because I'm asking you for the mean and standard deviation. So I haven't asked you to test the hypothesis yet. I'm just asking for a couple characteristics of that data. So then part C, test it. So that's when we go to tests. We are talking about the mean, so it's a t-test based off stats, sorry, our data. Mean of the null is 0, list should be L3, we are testing less than. Calculate, so we get our t to be negative 0.9068, and our p to be 0.2030. Alpha on this one was 0.05, p is greater than alpha, so fail to reject. Okay. Part D, the confidence interval, so what would you do? Stat, test, and number 8.